Well, shit. All right. This has been a long, interesting week. But it is time to repair this thing. This is a Tokyo high power. It will come in this box, this unbelievably heavy duty box. I have been inside this amplifier before. I determined that part of the PA system on this thing was completely fried. I went back to the owner of the amplifier and told him that this is what the deal was, and that the transistors for these are really hard to find. And he says to me, he goes, "No, they're not. I can go right here on eBay and find them. Why haven't you done that?" And I said, "Well, of course you can go find anything fake on eBay. If you guys don't know, eBay is like a dumping ground for garbage Chinese components, right? And in China, they will put anything on top of anything that looks something like a transistor, and they'll sell it to you." So sure enough, the final section transistors are available on eBay. And they are ridiculously cheap. Once again, they're fake. And I told him, I said, I don't want to use those parts. I've had to repair these a couple different ways over the years. I have the transistors that are in here were at one time made over in Oregon, right? And those transistors were awesome. There was a close copy of those made called the SC400. And they were made for my friend, Mr. Prime Minister, because he was going to use them in a bunch of whatever, different boxes. It's the Tokyo High Power 1.2kfx, and it's in almost pristine condition. It had taped to the back of it this fan filter, which will do something different than that. So I've gone and I've purchased some of those from him, and he made it very clear the last time I purchased 4 from him that those were the last 4 that he was willing to part with, that he had plans for the others. So I go back to the customer and I said, well, this is where you can get OG parts. It's like Mauser or DigiKey or something like that. And they're wildly, absurdly expensive. I don't know if you want to put the money into it or not. He came back and said, well, let me look into it. And then a few months later, this packet shows up. And it's a full up data comparison. I had another gentleman out there in the world that had one of these. He contacted me. And he said, well, I've got one. I'm going to try these parts that are a replacement part or a close to comparison part to the transistors that are in here. And he tested them and says he hasn't had any problems. I, on the other hand, am not interested or cannot spend enough time doing those kinds of things. It's the SD2933W. We got these from DigiKey. Well, he did all the R&D testing, so I went back to the guy that owns this amplifier and said, hey man, I've got a customer of mine that, or a friend of mine or somebody I've met, that said that they're going to try these parts and this might be a path to salvation for you to rebuild your very rare Tokyo high power. So when we got the green light, I went back to Mr. G, the guy that owns this, and said, hey man, you're good to go. And he immediately went out and purchase us some transistors. This amp has been here for 2.5+ years, slowly waiting to have the pieces fall into place for us to be able to do what we're going to do today. You guys have seen me repair many of these. This is nothing new to me. This song and dance here is something we've played out and danced with before. This is a good little 500 or 600 watt amplifier. Its total power consumption is like 1,000, 1,200 watts. Hence the name. So let's get the lid off and let's start breaking this down. This guy has been super chill. He's been patiently waiting. Patiently waiting. So what happened here? That needs to be mounted there. Okay. Anyhow, he's been super chill. He's been patiently waiting for me to get around to doing this. And believe it or not, contrary to the outside view of things, there's a plan to all of this craziness that goes on around over here on the daily. A lot of things are planned months and if not years in advance. Oh, come on. Let it rotate so I can show you on video. Here we go. So this folds out on an accordion hinge. As we have demonstrated in several other videos, we have to be very careful in the disassembly and the reassembly of the transistors in this particular device. The board has solder vias through it. And we've had a couple instances where guys have tried to repair this themselves and they end up putting too much solder into something and it'll pass through the board and it'll short the amp out. So all the parts get launched. This is what it looks like. I've shown this to you guys on many a YouTube video. So it's on a hinge. So to take this out, we pull all the plugs. It's a little different than the other ones I've worked on. The other ones had a plug here, so we'll have to unsolder this. We'll pull all these plugs. Oh man, so this has been modified a little bit, but we'll take a look at that. But then we got to strip the whole board off the spreader and off the heatsink so we can have access to both sides. The reason we have to have access to both sides is once again for the solder vias, because we've got to go in here and do a lot of this is going to come apart with solder wick. Right, some solder sucker process, some pulling on it, some peeling parts up, but if we don't put it back together with the board off, and I can have access to both sides of the board, when we go to put power to it, a couple of these smaller resistors down in here will short to ground and take the gate voltage right to ground, and the resistors will burn up. And then I have a whole nother issue that I have to fix where I've got to go in and work on really tiny traces and repair little tiny traces and try and get, because everything on this is through board soldered. It's much easier if I just take it all out instead of trying to repair it in the chassis. It, in the long term, will save us a lot of headache. So we'll get this out of there, and then I'm going to come back, I'm going to blow it out with an air compressor because there are a lot of little dust bunnies and stuff up in here. And we'll see if we can get this thing back up and going. But we do have 4 brand new transistors for the inside of this thing. And let's get it going. So I've taken a little bit of time and I've looked at this board, and this is kind of interesting development here. So the RF comes in through this plug. These, let's see, 1, 2, 3, these 3 attenuators are all hooked together, but it's like they've been bypassed. Right, so the RF comes in, goes through this bank of attenuators. Then we have a fuse. This is a 1 amp fuse. It's right here in this plug. So then, off of there, we have another set of attenuators. Then on the bottom side of the board down here, we have a removed trace, which then this is jumpered over, and that comes from this relay. The RF then goes through this wire over to the splitter. Well, I get to look, and we've also got a removed trace here And if I'm not mistaken, I'm missing this resistor here, which is R211. R211 goes to here, which is soldered through to ground. Why would somebody make this so low drive? Well, let me call the customer and see what he knows. This is a little interesting to me. Anyhow, our voltage adjustments are this. This is coarse. These are fine, and then our trip. And this thing's pretty straightforward, this amp board here. This down here, this cut trace has kind of got me questioning some shit. So let me make a phone call. We'll be back. So we took out all the transistors. I have yet to test them. I don't know what's going on. All I know is this PA board is dead. Okay, and I'd assume, digging into the last couple that I've worked on, that means the FETs are popped. We don't know that yet. I'm still on the fence with that, because now I've gotten to take it apart and look a little bit closer at it, invest a little bit more time in it. I don't know. What I want to cover was that if you guys choose, one of you guys out there try to work on your own Tokyo high power 1.2kfx amplifier, the board's got vias in it. So this is an uncleaned up, just pulled the transistors out of it. This is what it should look like once you get it cleaned out. Each one of these little holes is called a via. It allows us to have a trace on the bottom that you can grab and do stuff with and manipulate other things with. It allows it, and these are tinned. These pass-throughs are tinned, and it allows solder to flow through both sides. So in turn, let's flip the board over now, and let's back out our zoom a little bit, and you'll be able to see that we have these traces here. Now these are ground. It's not super hyper important that these don't have little bubbles of solder. As you can see, there's burbles of solder that are hanging down, and we see how they're all clean. This trace and this trace here, and this trace here and this trace here. If any solder somehow magically flows through here too much and it hangs down, boom, game over. And then now we're talking about replacing gate circuitry and a whole bunch of other shit up chain, right? So that's why I say it's just easier to go ahead and take it apart and spend some time with, you know, about 3 feet worth of solder wick to clean up one side. So now I got to go and I got to clean this side up. And once I get the board cleaned up, the next segment that we're going to do is we're going to test the FETs, okay? And I want to see if these are open or if they're still working. Just saying. If they're still working, that means we got other problems on this board that we have to figure out what the deal is. The one resistor that I said was missing, actually somebody has come through and they've repaired it, and they've got a 100K resistor, and that's R211. I see a 311 in this big book of knowledge, and it's right here. It might be a 211, but it sure looks like a 3 to me. And this is the section that we're talking about here. This section of the schematic is this section of the board right over here, this top portion. So I'm going to spend a little bit more time looking at the schematic. I see resistors 2.1, 310, 201, 207, 208. I don't know, I guess that could be a 2, but it's calling for a 61 ohm. And it's got 1/2 watt. Was what that's calling for. And then I got over here, I got resistor 212. So somewhere farther up this chain is 211. I don't know, I spent a little more time looking at this, I think. There's R210, 27, 201, 202, 204, 210. I'll be back. Alrighty. Let's grab our little atlas. Let's see what it has to say about things in the world. So gate, source and drain, and it says MOSFET in channel. 2.185 volts. All right. This FET is good. All right. Look up to here. Look up to here. MOSFET. 2.27 or 2.22. 27. MOSFET. 2.223. Interesting. Interesting. $2.147. It's way low. Interesting. Very, very, very interesting. Well, so all four of the FETs are good. Let's look around. Let's go find out why this thing isn't working. So either it doesn't have gate voltage, or for some reason it's going into protect mode. And I'd probably lean towards the fact it's going into protect mode, which is going to be a little bit hard to track down with it ripped all apart. So that means, guess what? I got to put it all the way back together. So what I'll do before I put this back together is I will take and I'll put capped on tape across the back side of this and across the back side of this, because once I put this together, I don't have to take it apart anymore. There's so many little things on here that either can get little piece of solder or water on them or whatever. I only want to sand. This gate voltage modification over here, as I previously stated, this is our coarse, right? And then we have a secondary coarse tune, and then we have a very fine adjustments. So this has got some capacitors across it. And normally what it'll burn up is these little tiny bastards, these R19, R222, R224, and R226. And these resistors are all good. I've tested them. So when I saw that those resistors weren't popped, that's when I started going, I bet you these FETs are actually good and there was something else wrong with this box. The whole drive attenuation bypass over here in the corner, man, I don't know what to make of that. I'm going to have to sit around and think about that one for a hot minute. I mean, this is very clearly cut. So is this side. You very clearly see where it's cut, right? What were they trying to achieve and what were they trying to do other than make it a little bit lower power input? But why would you want to do that? And then sell it and not tell the guy that bought it anything about it, because then that ends up causing a big problem in itself. I don't know, but that's what's happened. All right, well, let's start putting this back together and let's go figure out why the hell this thing ain't working right. Okay. So when I took this apart just now to pull that out, I couldn't help but notice that this aluminum bar, which fits here, was snapped off. Now, is that going to make the difference on how this entire thing works? Taking into account there's a committed ground that goes to the back side of this RF deck, the PA board? Probably not. But I went ahead and I drilled this out and I tapped it, and we're going to go ahead and replace it because it was Well, it was one of these standoffs, which I've never seen used in a Tokyo high power until I opened this amp. Anyhow, it was snapped clean off, so I went in and I drilled that out, and then I retapped it, and I'm going to reattach this bus bar. Then we're going to put the RF deck in, the PA board. We're going to sit it in here, hook it all up, and then I'm going to create a little plate that goes over here to do the bypass. We're going to plug this thing in. I'm going to put RF into it, and we're going to key it, but without the transistors in it. And I want to see if the RF is making it down to the board. And then in turn, I want to see if I can meter from the output back to the amp board itself. We have to do this to make sure that it's not one of the relays that quit. I have a feeling it has something to do with the board yet, but we'll see how it goes in testing. I blew this out with an air compressor and got it cleaned up. So let me get this screw put in. We'll get the screws put in that hold this in place. We'll get all of our other sense wires hooked up, and we'll see if this thing actually does its mojo without going into fault. All I got to do is step on the pedal and it'll key. Now we're not going to put a signal into it. We're going to use oscilloscope and a signal injector to trace how far RF is making it. And if it's making it to the input side, and then if we're seeing RF from the output side to the output coax connector, that's a great plus. Then we'll go ahead and we'll put in the transistors. So yeah, see here, this is the aftermarket standoff screw thingy that went here. It got sheared off. Let's get this fixed. We'll move forward. Okay, so we're all set up. Now this fan back here, it's broken, and I'm gonna have to do some gluing on this, but we'll go through and we'll fix that here in a minute. I can fix that. So what we got here is our reduction probe going over to our oscilloscope. Now, very crudely, instead of using the signal generator, I'm just going to use one of the bench radios, and I'm going to put like a 1/10 of a watt in this thing. All right. We're going to look at the input side first, as far as signal, and make sure we're getting signal down here to the board. Because if you guys remember, just a couple segments ago, I had to repair this trace, top and the bottom side of the board, to get the attenuator in place. I don't understand why the attenuator was bypassed. All the resistors that represent the attenuator circuit are all fully functional. The only thing I can think is maybe the previous owner was in here, and they decided they needed to make it so they could run it with like a 25 watt radio or something. I don't know. We're gonna put it back to stock because after talking to the owner, who's now decided he wants me to just repair this, and he's gonna keep it as a spare, we're not gonna sell this thing apparently. Whatever. Yeah. He's got a 100 watt radio, so we need to set this thing up to be able to be used per stock. So I've got the reduction probe hooked up to the input trace of this piece of coax. So all we're measuring is if the RF has the ability to go in, go through the transmit receive relay, and make it here to the attenuator, this end. Then we're going to remeasure it from this end of the stack. While we're in there, we're going to measure to make sure we've got the right volts for the circuit, and we're going to make sure that we got the right gate voltages before we go and put the transistors back in. I'm not seeing a whole lot that's wrong with this. I'm not. I haven't got an opportunity to test the output filter relays yet. We'll get there. And when we go to do this test on the other side, we're going to run it in reverse. So we're going to inject signal from here, because remember, there's no finals in here to hurt. They're sitting back here on this piece of paper towel. We're going to inject a little bit of signal back here and make sure we're making it down to the board. If that's the case, if I got gate voltage, there are no burnt components on this thing, and I've got the ability to put signal in and pull signal out, we have to question, was this broke up on the inside? What was the problem? This black wire coming off this 50 volt supply goes directly down and goes to the heat sink. So I don't know. With these things, with the integrated circuits that they have up here in the front that control everything, it's a little iffy. There could be a problem up here. There could be a problem back here. But we'll see. So we've got the oscilloscope hooked up. Now let's go back down over here. Let's turn the amplifier on. We'll go in here and we'll probe. We got 47 volts here. We'll step on the pedal and we'll put it in transmit. Now I don't know if you guys can see it or not. There's a little bias indicator LED that's right here. That's kicking on. That's a good sign. That means it's not going into fault. So we'll probe here. 2.7 volts. 2.6. 2.68 and 2.64. Okay, so we have all the right voltages. So now let's go see what we've got for input signal. So we'll go ahead, we'll step on the pedal. We'll inject a little bit of signal. So we now know that the RF is making it in through the connector, down through the relay, and to the attenuator circuit. So let's go in here, we'll grab the other end of the attenuator stack. Now we should see roughly half the amount of signal that we just put in. So we'll step on the pedal, and we do. Okay, so the attenuator stack is working properly. And when I say stack, that's my language. Okay, it's not, it would be the attenuator bank, the attenuator circuit, the attenuator load. I use the word stack. Tomato, tomato. Okay, so let's go over here. We'll hook that to that. We'll come here. Let's go probe right here. So let's go over here. We'll step on the pedal. We'll inject a little bit of signal. Okay, so we're seeing signal out. Now let's go look at it on the other end of the circuit, down here on the board. See if I can probe in here and not short anything out. Should be right about there. Nope, still don't have it. Well, hell, let's grab it here on the front of the transformer. Oh, there's going to be 50 volts. It's going to overload the meter. So I got to grab it at something decoupled. So yeah, that would be here. Yeah. Let me reprobe and show you. Okay. Okay, so we got signal going both ways and nothing's tripping into fault when we step on the pedal. We've got all of our proper gate voltages. Let's see here. Yeah, we got full relay movement. And nothing's going into trip. All right. Shut this off. And we'll let the 50 volts bleed off. I'm going to go fix this fan. I can't listen to this rattle anymore. We're going to put a new little dust cover on the back. And I think it's time to drop some FETs down on the holes and see if we can get this thing to come back. I don't know what else to do. Everything else tests out. I got RF in, I got band switch, I got filter, I've got gate voltages in the proper ranges, I've got all the ducks are lining up. Initially, I went into this thinking that the FETs were popped, and that's what been the delay is this entire time. Come to find out it's not that. It might be something else. It could have just been as simple as this being broken. We'll see. Okay, so we got the amp set up for 80 meters here on the front. We're going to use the ICOM 7300 and AM. We're going to put 1 watt into it. I want to check the gate voltages. All the transistors are back in. Everything's mounted up. It's basically 99% put back together, enough for us to operate it. So we're hooked up to the dummy load, and I just want to see if it'll pass RF. That's test number 1. Test number 2 is we're going to put in transmit mode, and we're going to measure each one of the gate voltages. And test number 3 is I want to see it operational. Like, I want to see what the transistors do when we go and we put power to them. 1 watt is enough to get the transistor to activate. Of course, when we stand on the foot pedal and activate the gate voltage, we should be able to see the transistors turn on with the FLIR. So let's give this a minute and it'll boot. Okay, so we're not going to touch this. We're going to leave this alone for a minute. Everybody's first and always desire is to immediately hit the button. Let's see if it builds power. Let's walk into this slow. These components are expensive. It's very time consuming to change them. Like, I'm probably 6 hours into this process now, and I'm just now getting it put back together. Most of which was taking the transistors out and repairing the solder joints, cleaning everything up, and then putting it back together. It's ridiculous. But, so Tokyo High Power built them, and hey, it's Tokyo High Power. Come on. Fan, we repaired it. We got a new fan guard on here. We got a new filter to go on the end of that because the other one was so shattered. These things are so delicate and almost worthless. All they do is they trap dust and then make it breathe less and less and less and less and less. I'm not a big fan of those. I'd rather have dust on the components than it not get enough air circulation. It's just me. If you're running a blower or something like that, that's a different story. But okay, so right now the transistors have got voltage on them. Hello. Well, let's reboot this. For some reason it froze. You know, that's what I miss. The old unit that I had, man, I could turn that thing on instantly and be working with it. This thing, I spend more time waiting for it to boot and more time waiting for it to refresh as I'm using it. If anybody out there from FLIR is listening, which I'm sure you guys have fixed in your latest version that cost $9 grand. All right, let's let this thing boot. We'll be back. Okay. So we have a relatively cool RF board. We're going to click this on. We're going to click this into operate. And then we're going to keep an eye on this LED right here. And we're going to look at the FLIR, and we're just going to step on the pedal. Okay, got one transistor that turned on for sure. Of course, now the FLIR has to calibrate. Okay, so let's see what we got for gate voltages. No gate. No gate. Okay, got gate voltage. Got gate voltage. Got gate voltage. Got gate voltage. Okay, so it's all roughly uniformly the same. So just because the transistor checker said, oh yeah, everything is good, does not necessarily mean that the transistor is actually operating. I've had them where they test fine, then you put them in circuit, and as soon as you put power to them, they fail. If you remember when we tested these, the tester said that it was 2.6 volts. We're roughly at 2.6 volts. So 2.7, 2.61, 2.68, 2.63. You see how that all changed as soon as we put the parts in? If you rewind the video back, you'll see that there's a voltage difference. So Okay, so I want to see if it makes power. Just the smallest amount's all we need. So we're able to talk through it according to this. A little bit of carrier going through. Let's go over here. We can see the needle moving. So step on the pedal. Oh. So we are amplifying. All right, let's turn our FLIR back on. So we are making power. All right. Just turn the power up a little bit. It's about 200 watts worth of carrier. All right, let's go over here to the front. Power, forward power, tracking, reverse power, good, volts, good, amps, good. Running through the motions over here. So forward power, reverse power, volts, amps. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2. Okay, we're at 35%. So now we'll switch over to sideband. Hello, 1, 2, 1, 2. Step on the pedal. Hello, 1, 2, 1, 2, 1, 2. 1, 2, 1, 2. Okay, so we're making 500 watts of power with very small amount of drive. Let's show you this. Hello, 1, 2, 1, 2, 1, 2. So we're on sideband, we're putting about 15, maybe 18 watts of power in it. Hello, 1, 2, 1, 2. Making about 425. Remember, this is a 700 watt max piece of equipment. Period. We haven't tripped the overheat. We have not tripped the overdrive. Hello, 1, 2, 1, 2, 1, 2. All right, before we go any further, let's shut this down. Let me unplug it from the 15 amp supply that feeds the workbench. Let me reach down here and we'll hook into a dedicated 30 amp 110 outlet that I have just for these occasions. That allows us not to have quite the amount of voltage sag that we were just having. We'll see if that increases our power output at all. Hello. Hello. Oh yeah, it helped a little bit. Not much, but a little bit. And the fan isn't slowing down when we modulate either. Hello. Hello. It wants to give us more. So we'll turn our drive up to 40. Hello, audio, 1, 2. There's 600 watts. Okay, output power of the radio is up to half. Hello, audio, 1, 2, 1, 2, 1, 2, 1, 2. It's beautiful. Hello, 1, 2, 1, 2. Input attenuator's looking nice and grand. So this thing's working. I mean, it's working. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. What I'm looking for is to see if the transistors are turning on evenly and then cooling off evenly, and I don't have one that's getting hotter than the other. The reason we've got to keep an eye out for that is to make sure that all the transistors are setting flush into the heatsink and make sure that they are turning on at the same rate. There's another way to measure that, is to measure the input gate current and input source current is another way to measure that. So if they're all pulling the same amount of current, we all know that they're working roughly the same, right? So I'd rather do it the lazy man's way instead of having to put up a donut ring on every one of these things and measure all the current draws. I can just look at it with the FLIR and go, okay, yeah, they're all heating up roughly at the same rate, which they are. So I can put that away. Let's go ahead and let's try 160 meters. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Let's go over here. 160 at 50% power. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Okay. So now we've already done 20, or we already done 80. Let's go up here to 20. This is all we're going to put in it for drive. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Step on the pedal. Oh, it says overdrive on the front. So we got it to trip. How'd it go into overdrive when we didn't have it in operate? Hello, 1, 2, 1, 2, 1, 2, 1, 2. Yeah, we're gonna have to put the rest of that attenuator in play. That's too much. Too little drive. Hello, 1, 2, 1, 2, 1, 2, 1, 2. So put the amp back in standby. And this is what I did earlier is I went to key it to show you how much we had for drive going in. And I didn't put the amp into transmit. Hello, 1, 2. See that? So it clicked into overdrive. So I'll reset it. Then I step on the pedal. Hello, 1, 2, 1, 2, 1, 2. Interesting. Still, we're only putting hello, 1, 2, maybe 35 watts worth of drive in this. So this is 10 and 14. So we'll say 14. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2. All right, so that's working. 18 through 21 megahertz. So say 21 megahertz. Hello, 1, 2, 1, 2. Cycle this. Hello, 1, 2, 1, 2. Looking good. Now 24 and 28, so we'll jump up to 10 meters. Hello, 1, 2, 1, 2. All right, no problem. Hello, 1, 2, 1, 2. Okay, so it's working all the way across the band in all modes. I want to hook up the rest of the input attenuator and see how that affects everything. So let's set up for, we'll go back down to 80. And with our current drive level, let's go in here and get a measurement. Hello. Seeing roughly 600 watts displayed with hello 1, 2. Maybe 25 watts worth of drive. Now what I'm going to do, so let's come up in here, you guys. Is it going to focus? It will. Right here, you'll see that a couple of the attenuators have been bypassed. We're going to hook those back up. So the RF now sees more of a balanced 50 ohm load going in. And that should significantly knock back our signal input even more. I really think that somebody was trying to make this into a low drive unit. And I think that my customer didn't know. Because remember, this whole end of the bank of attenuators was bypassed. So even with 35 watts of drive, we're achieving full output. We still got this half of the bank bypassed. So we'll bring that in line and we'll see how that affects everything, if anything. Okay, so this is a little bit of what I was afraid of here. So same drive, same. The only difference is we've got two of the attenuators hooked up. hl-1.2. So it costs us about 100 watts, which is what we're looking for, but this is not what we wanted to see. I'm going to look in here on the SWR bridge. hl-1.2, even with all the attenuators hooked up, the output power drops down to 200 watts, but this jumps to a 3 on the input SWR versus it being perfectly flat before. So it tells me, even though that these resistors measure okay, there's something wrong with them down here. So I'm going to go and see if I can find these resistors. 1, 2, how long they're going to take, and then 3, I'm going to call the customer and see if he's okay with leaving this as a 35-40 watt drive piece of equipment, and then I clearly mark it as like max 35 watts peak for drive, or if he wants to pay to have the resistors put in / attenuators put in and have it fully restored so you can put 100 watts in it. We'll see. It's all entirely up to the customer what he wants to do. If he is not interested, like if I was going to restore this and put it out there for sale, I would have to have these attenuators in play, right? But if the customer doesn't want it, hey, who am I to judge? It might save him a couple $100, and his amplifier is fully working. You just got to remember that you can't put more than 35 watts in it. Then we'd have to go and adjust the overdrive protection. So let me go scavenge these parts. I'll be back. So sometimes you find yourself down this rabbit hole looking for a problem and you just can't find it. Well, I went and I looked up the resistors, the attenuators, and they ended up being about $6 a piece. I can find them. But then I was thumbing through the book, and if we look down here in the book, if we look really close to this grainy picture, we can see that these attenuators aren't even hooked up even in the book. So that made me go, maybe I don't have a problem here. This whole section's hooked up. So we did that portion of the repair correctly. So then I went and I thought, you know what? Let's go grab, I've got one of these that's got the central processing unit and the front of it's blown out, but the PA board's the same. So when I pulled it, and sure enough, it's got those resistors bypassed. Well, not bypassed, just hooked in series parallel. So I went ahead and I put everything back the way it was. And this box runs great. So what I want to do is we're going to put this on 28 megahertz. And what that allows us to do is to have the spectrum analyzer out where you guys can see it. And what I mean by that is most people in the radio world that consider themselves to be technicians have made it very clear that I need to have my spectrum analyzer set much wider. So I've got it set at 500 megahertz. Well, on a 500 megahertz scale where I'm working way down here, it just shows up as a bump over here on the edge of the screen. Like if I'm down at 160, 80, 40, and so on, and 20, there's not enough bandwidth. As in, like, the bandwidth isn't compressed down enough to where I can show you there's no second and third order harmonics. So we're going to show you that here real quick. The other thing that I want to do is let's go ahead and ramp the power up. So the amplifier's off. That's what we were putting in it roughly before. So we'll go ahead and we'll crank this up to full power. 1, 2. And we'll go ahead and we'll put that in the amplifier. 1, 2, 1, 2, 1, 2. So now with full power, we'll go ahead and we'll switch this over to AM. So that's what we're going to throw in this thing for a carrier. It's about 20 watts. 20 watts output gets us about 480 watts out. So let's go over here. We'll put our amplifier in standby. That's the radio. Put the amplifier into operate. Amplifier. That's the amp. And as you can clearly see, there is no second and third order and fourth order harmonics. That's with a heavy saturated signal going out. Okay. I have to show this test. It's a pretty important one. It allows us to maintain that, well, allows us to be able to say to people this thing is maintaining frequency bandwidth, which tells me the notch filter board's working properly. It does this on all bands. Let me show you what I'm talking about. We'll go down here to 80 meters. Ship menu. Meter, there we go. So we'll put this in standby. So same amount of drive power before. Roughly the same amount of output power. But now let's go over here to the spectrum analyzer. I gotta remember to quick key in this thing with it and operate. Okay, so radio, that's the radio. You see it? See what I mean? How it doesn't, there's not a big signal spike there. We'll put the amplifier in line. Just looks like noise at the bottom end of the scale. But as we can all clearly see, there's no second or third order, nothing. Which tells me that this amplifier is good to go. Discovered a little thing. Remember how this kept kicking into overdrive? Yeah, that's my fault, operator error. So put that in standby and key the radio. It doesn't trip. Put that in operate without stepping on the foot pedal. Goes into overdrive, which come to find out is one of the safety functions inside this amplifier. So everything is set. I think I've got, which I'll probably cover in the next segment. I've got the meters set up so that they're titties, spot on. I mean, it's as close as we're going to get for a relative meter movement. The only thing I want to test it now is to put the lid on it, make sure we've got adequate airflow, and also make sure that we're maintaining frequency still. So, because the proximity of the cabinet can change how some of the circuitry works. Let's go do that. Okay, so we got good airflow now through the cabinet. Fan is running, air is moving. Let's go over here. And let's go to AM. Now we're going to do 100% power out of the radio, which looks like that on AM. Put this in operate. We see about 400 watts on the peak side and about 210 on the average, right? So let's come over here. Let's take a look at this meter. Oh, it went into overdrive because I didn't hit the foot pedal quick enough. So now we're seeing like 325, right? 325. So our meter on the front is showing us a relative measurement, which I consider to be somewhat factual. So we could use that as a relative form of measurement. Now we'll switch over to sideband. Hello. Did it again. Hello. 1 2 1 2 1 2 audio. About 510 watts. We'll come over here to the front of the amplifier. Hello. Hello. Looks pretty accurate to me. The peak meter is showing us a little bit more, of course. Hello. Damn, I did it again. hl-1.2kfx, 700 watts peak. So you take away from this meter, this one here, what you need, and this one here, what you need. All I'm showing is that the meter on the front of the amplifier is relatively correct, so you can use it for a relative form of measurement. That's it. All the tests are complete. Gentlemen, let's take a minute and say thank you to all the Patreon supporters that are down here. I try to give them an update every day that I'm out here working on the workbench. They have access to the videos for a full 48 hours before you guys on YouTube get them. They have access to a lot of videos that aren't on YouTube, believe it or not. I try to do about one update every other month, video-wise for them. Plus, well, they know everything I'm working on, so if I'm doing a masterclass build or a new product, they get to see it first and they have first option to buy. They also make it possible for me to be able to give the big giant finger to YouTube and not have to worry about ads. So if you're watching my video content and you don't have ad blocker on, you should be thinking about why this entire time you haven't had a single ad interrupt your viewing pleasure. It's because of these guys here on Patreon. So we give them a big thanks. I want to give a big shout out to Mechman, Siglent, Bird, Coaxial Dynamics, Penalabs. Penalabs is running a 5% discount special. If you buy any product from Penalabs and in the checkout you type in BBI amps, you'll get a 5% discount. I do not see any of that money. They're just doing that for a thank you to all of you guys that watch and participate. So spread the word. Discount code BBI. This thing is done. I'm going to go box it up. It's going to get shipped out of here tomorrow. The gentleman that owns this amp, Mr. G, has decided to keep it. Initially, he was going to have me sell it. Here's your transistors that are coming back to you, because I know how much they represent in money. But now you have a backup set of finals for this amplifier, and these are legit. So, gentlemen, I want to thanks everybody for hanging in there, watching, and carrying on with me here. You know, I haven't cracked a joke this whole video for some reason, and I don't know why. I'd like to get into working on more of these, by the way. More amateur equipment, more solid state stuff. I'm very interested in pursuing that. So if you've got something along this lines or in this order that you want to have worked on, give me a call. We're going to be taking on new work here probably in the next 3-4 months for 2025. So on that note, we're going to go over here to our old 110 outlet. And we're going to say, look at that, 3 holes. All are good. Kind of reminds us of when she was young and open for new things. Okay, on that note, we're going to say one's hot, the other one's not, and the other one goes to earth. I'll see you, gentlemen. Remember, when she was younger, and she was a little bit more relaxed and open for other things. It is what it is. I'll see you guys. Click, click.